Hey everybody, and welcome to part 2 of lecture 15. In part 1, the part that you just got through viewing, we talked about equations of a line in the xy plane. Here we're going to talk about some special cases. We're going to talk about horizontal lines, vertical lines, lines that have a slope of 0, and lines that have undefined slope. And to set the tone for this discussion, let's take a look at an example that we saw in the previous video, part 1. This is the example that I'm talking about, and it asked us to compute the slope of the line which contains the points 2, 6 and 5, 6. And we remember what the formula for the slope of a line is. A line which goes through 2 distinct points. The slope that we represent by the letter m is equal to y2 minus y1 over x2 minus x1. And x1, y1 and x2, y2 are distinct points on the line. Arbitrarily, we'll let this be the first point. So we call this x1, y1. And we'll call this the second point, x2, y2. And now we just pop everything into the formula, and out comes the slope. y2 minus y1, that's 6 minus 6. x2 minus x1, that's 5 minus 3. I'm sorry. x2 minus x1, that's 5 minus 2. And we get 0 divided by 3, which is 0. And we saw that in the previous part of this lecture, and we thought, well, that's weird. The slope of the line is 0. Let's explore this a little bit. Let's draw a graph of the line that contains these 2 points. And if we remember, we really only need 2 distinct points to graph a line. We have 2 distinct points. Let's draw a graph of the line that contains these 2 points. Okay. We have our xy coordinate system drawn here. And we're going to plot these 2 points. First of all, let's plot x1, y1. The coordinates are x equal 2 and y equals 6. So here's x equal 2. We go up to y equals 6. And bingo, there's 2, 6. That's x1. Now let's plot our second point. x2, y2. x2 is 5, y2 is 6. Here's 5, x2 is 5. And we go up to y equals 6. So here's y equals 6. Here's x equals 5. Beautiful. Okay. We have 2 points on a line, 2 distinct points on a line. That enables us to graph this line. Let's see what happens when we connect the points, okay? And let me use a red marker here. No good reason, just let me do it. I like red, that's all. We draw a line that goes through the points 2, 6 and 5, 6. And I'll be a son of a gun. Do you see where it intersects the y-axis? It intersects the y-axis at y equals 6. Huh. Well, that tells us something. Let's think about what it tells us. First of all, notice that with two distinct points, we have the same y-coordinate. And if we get a third point on the line, it has the same y-coordinate as the other 2 points. So far, all of the points on this line have the same y-coordinate. Now let's notice something else too. This line is a horizontal line. It goes straight across. This is characteristic of every line that has a slope of 0. If it has a slope of 0, it doesn't go up and it doesn't go down. It's a horizontal line if it has a slope of 0. So here's the first observation. And we want to make clear this is not just a coincidence. Whenever we have a horizontal line, the slope is 0. And whenever the slope is 0, we have a horizontal line. Our line has a slope of 0. That happens exactly when the line is horizontal. What else do we notice? It appears that the y-coordinate of every point on the line is the same. Y-coordinate of 6, y-coordinate of 6, y-coordinate of 6. You know what? I'll finish this. The y-coordinate of every point on the line is the same as the y-coordinate of every other point on the line. But I think I could have said this better. Every point on the line has the same y-coordinate. This is characteristic of horizontal lines. Now there's one other thing that we need to consider. Remember in the previous part of this lecture, part 1, that we talked about the slope-intercept form of the equation of a line. Let's see what happens here. Now, before I look at this, let me remind us all that we're working with the same example. We're working with the line that contains the points 2, 6, and 5, 6. So this is not really a new example. We're taking the same example, the line going through the points 2, 6, and 5, 6. We're taking the same example, and we're just milking it for all it's worth. In this part of the example, we want to find the point, my goodness. Oh, forgive me. We want to find the slope-intercept form of the equation that contains the points 2 and 6. Find the slope-intercept form of the equation of the line that contains the points 2, 6, and 5, 6. And what does that point slope form look like? Let's remind ourselves. Y equals mx plus b. And we might remember m is the slope and b is the y-intercept. Now let's take all of the information that we've gleaned from this example and plug it in here. Let's see, what did we find out? The slope, m equals 0. For this line, the slope was 0. Remember that? And what about the y-intercept? What was the y-intercept? 6? Yeah. The y-intercept well, I'll tell you what we're going to do. We're going to take these values for m and b and plug them into this equation, okay? And that will give us the slope-intercept form of the line that contains these 2 points. Here we go. M is 0, and b is 6, 0x. That's just 0, right? So the equation boils down to this. Y equals 6. Believe it or not, this is the slope-intercept form of the line that contains the points 2, 6 and 5, 6. Well, where's my mx? It's right here, 0x. It's just 0. But this is just y equals a number. That's right. Now that doesn't look like the slope-intercept form of a line that we've ever seen before, right? What was different about this line in this example? What was different about this example as compared to the examples before when we've worked with the slope-intercept form of an equation of a line? Here, the line was horizontal. The slope was 0. That's why this equation looks so weird. Now let's recap that. See this? This is what the equation of a line looks like whenever the line is horizontal, or whenever the slope is 0. Y equals some number. Now, what exactly does this mean? It means whatever x is, for every value of x, y is 6. If x is 0, y is 6. If x is 1, y is 6. If x is 5, y is 6. If x is a ham sandwich, y is 6. No matter what x is, y is 6. The y coordinate of every point on the line is 6. And let me just redraw the graph of this line, just to remind ourselves that this is true. Here's the graph of the equation y equals 6. It goes through the points 2, 6, 5, 6. It also goes through the point 6 on the y-axis. Well, suppose x is 3. What then? It goes through the point 3, 6. Well, suppose x is 4. What then? It goes through the point 4, 6. Suppose way out here, x is a ham sandwich. Yeah, let's say that. X is a ham sandwich. It goes through the point ham sandwich, y equals 6. No matter what x is, y is 6. And the graph of this equation is horizontal. y equals b, where b can be any number. It's horizontal. Slope equals 0. The y-coordinate of every point is the y-coordinate of every point is b. These are the characteristics of a horizontal line. Now, let's just look at a bunch of examples. We're not going to belabor the point like we did on this past example. We're going to look at a few examples, maybe spend about a minute on each one, and go on to vertical lines. Graph the line y equals 3. What do we know already? It's horizontal. Slope is 0. And the y-coordinate of every point is 3. Oh, there's something else we know too. Specifically, if the y-coordinate of every point is 3, and this is an important point. If the y-coordinate of every point is 3, then the y-intercept has got to be 3. So in particular, anytime we have the equation of a horizontal line like this not only gives us the y-coordinate of every point on the line, it gives us the y-intercept as well. So to draw this line, we go to the y-intercept, which is y equal 3. And we draw a horizontal line through this point. Voila! There it is. Let's do one more. Graph the line y equal -2. Okay, what do we know about this line right off the bat? It's y equals some number. So right off the bat, the line is horizontal. Let's see, what else do we know? If it's a horizontal line, the slope is 0. The y-coordinate of every point on the line is -2. And more specifically, the y-intercept is -2. So to draw this baby, we're going to go to the y-intercept. That's this thing, -2. And I'll tell you what, let me plot my y-intercept. There it is, y equal -2. Now I'm going to draw a horizontal line that goes through this son of a gun. And here we go. This is the line y equal -2. There, we did it. As I may have hinted a second ago, now we're going to look at vertical lines and undefined slope. And to do that, we're going to consider an example that is the alter ego of the example that we use to introduce horizontal lines. Here's the example. Here's the alter ego of our first example. Graph the line which contains the points 6, 2, and 6, 5. Okay, I think I can do that. Okay, we're going to graph the line which contains the points 6, 2, and 6, 5. We have two distinct points. Those two distinct points determine uniquely one line. So let's go to x equals 6, y equals 2. So there's 6, 2. And let's go to x equals 6, y equals 5. So here's the point 6, 5. And let's get a straight edge so we can really draw a good line here. Okay, there we go. And son of a gun, we notice the line is vertical. Okay. What's the slope? Our slope formula says the slope m is equal to y2 minus y1 over x2 minus x1. So we have to get two distinct points. We'll call this the first point, x1, y1. We'll call this the second point, x2, y2. And let's see what we get. y2 is 5, minus y1 is 2. x2 is 6, minus x1 is 6, so that's 3 over 0. And you know what? This is not going to be equal to 0. We're dividing a non-zero number by 0. That's undefined. Huh. So we have a line that's vertical and its slope is undefined. These two things always go together. You don't see one without the other. Whenever we have a vertical line, the slope is undefined. Whenever the slope is undefined, we have a vertical line. Now, what else about this example helps us characterize a vertical line? You catch that? The x coordinates are the same. As a matter of fact, not only are the x coordinates of these 2 points the same, but here's our x-intercept down here, and the x-coordinate of the 2 points are 6. The x-intercept is also 6. So let's see, the x-coordinate of every point is 6. The x-intercept tried to plug all of this information into the slope-intercept form of a line, we couldn't do it because the slope's undefined. There's no value for the slope that we can plug into the equation y equals mx plus b. But we can follow the pattern that we have with horizontal lines and essentially do the analogous thing for vertical lines. And we'll do that. Remember that if we have a horizontal line, the equation of a horizontal line is y equals b, where b is the y-intercept. So by analogy, the equation of a vertical line, what do you think it's going to be? Here's what I think. X equals A where A is the x-intercept. So this is how it turns out. We can't use the slope-intercept form of the equation of a line to derive the equation of a vertical line. Because the slope is undefined, we don't have a value of the slope to plug into the slope-intercept form of the equation of a line. But we can follow the pattern set by horizontal lines. We have a horizontal line. The equation is y equal b, where b is the y-intercept. We have a vertical line. The equation is x equal a, where a is the x-intercept. In our example, the line contains the points, what, 6, 2? And 6, 5. X-intercept. Did you get what the x-intercept was? Check your notes. The x-intercept was 6, wasn't it? So the equation of this vertical line is going to be x equal the x-intercept. Now we are going to summarize what we just did, do a couple of examples, and we are going to be out of here. Okay. X equal A, where A is any number. X equal A is the equation of a vertical line. So if we have this equation, it's a vertical line, and that means the slope is undefined. That means the x-coordinate of every point is the same as the x-coordinate of every other point. And the x-intercept is A. Then when I say the x-coordinate is A, I'm talking about this number right here. Whatever this number is, that's the x-coordinate. What could be easier? Let's do an example or two, okay? Here we go. Graph the equation x equals 3. What's the first thing that we probably realize when we see this equation? The first thing we probably think is, son of a gun, this is a vertical line. The second thing we might think is, this is the x-intercept. So we know that the line goes through this point, 3 on the x-axis, and it's a vertical line. We know how to draw a vertical line, don't we? Straight up and down. Let's do it. It's a vertical line, and it has to go through this point, x equals 3. Okay. There we go. This is the graph of the line whose equation is x equals 3. We're done. Let's do one more. Graph the equation x equals -2. First thing we realize, it's a vertical line. Second thing we realize, the x-intercept is -2. So the line goes through this point on the x-axis, and it's vertical. We know how to draw a vertical line through x equals -2, don't we? I think we do. And here it is. There's our vertical line, x equals -2. Now, very last thing, I'm going to introduce you to a special vertical line and a special horizontal line. I do have to mention these two things. Look at the x-axis here. It's a horizontal line. So it has to be given by the equation y equals some number. And that number happens to be the y-intercept. Well, where does this horizontal line intersect the y-axis? Isn't it right here at y equals 0? So the equation of the x-axis is not x equals 0, but the equation of the x-axis is y equals 0. Now, if we can do that with the x-axis, we can do something like that with the y-axis also. Here's the y-axis, and it's a vertical line. And every vertical line is of the form x equals some number. As a matter of fact, it's x equal the x-intercept. So where does this vertical line intersect the x-axis? Oops. Where does this vertical line intersect the x-axis? Isn't it at x equals 0, this is the x-intercept. The equation of the y-axis is not y equals 0. The equation of the y-axis is x equals 0. Now let me summarize this. Equation of the y-axis, x equals 0. Equation of the x-axis, y equals 0. And let's see if it makes sense. X-axis, that's this line right here. What's the y coordinate of that point? Let's see, here's x equal 1, x equal 2, x equal 3, x equal 4, x equal 5. This point right here, the x coordinate is 5, what's the y coordinate? 0. This point right here, the x coordinate is 4, what's the y coordinate? 0. The y coordinate of every point on the x-axis is 0. So the equation of the x-axis is y equals 0. And we can do the same exact thing with the y-axis. That point, the y coordinate is 4. What's the x coordinate of this point? It's 0, isn't it? The y coordinate of this point is 3. What's the x coordinate of this point? It's 0 again, isn't it? The x coordinate of every point on this line, the y-axis, is 0. So the equation of the y-axis is x equals 0. It sounds counterintuitive if we don't reason it out. The equation of the y-axis is x equals 0. The equation of the x-axis is y equals 0. That might be worth our while remembering. And now, absolutely positively, this is the end of part 2.